Hi everyone, good afternoon. Welcome back to the training. Am I clearly audible to all of you? Yes, perfect. Okay, so we will start in 2 minutes more and we'll discuss about some really interesting topics. So let's connect in let's continue in 2 minutes. All right, I'm sharing my screen. Once you guys are able to see my screen, please confirm. Okay, perfect. Okay, let's get started. The topic for today is understanding the wireless networks. It's quite important that we understand how wireless network works and what all frequencies, what all devices, and what all mechanisms are used in wireless connections. The connectivity we have discussed so far was completely about wired connectivity, where there was a router connected to a switch, and all my end devices were connected to my switch using a cable. In this type of connectivity, we definitely do receive a better, we can say, connection, or we can say a better reachability to the devices. But there are some limitations also which we have to face. What are these limitations? First of all, that I am supposed to be paying for all this installation, right? Installation cost is there, right? What else do you think, along with this installation cost, what other are the limitations when we speak about the concepts of wireless networks? Any guesses? Interference blocking points. In a wired connection, I don't think there would be much of interference. But yeah, there are problems like you have less scalability as compared to wireless network. You have no mobility. That means you cannot just pick up your laptop and move around. Whereas when we speak about wireless networks, where there is a device which is transmitting radio frequencies, so my devices would connect on radio frequencies. In this type of connectivity, I first of all have mobility. I can take my PC and I can roam around anywhere in the covered area or in the area where there is a coverage of my wireless network, right? That's first of all the very first benefit. Secondly, there is no installation cost. It's scalable. Installation of cables are not required, right? But then, along with all these pros, there are some cons as well, which we have to address in our wireless networks. What are these cons? Security is a major problem with a wireless network. In a wireless network, security is something which is something which you need to be very cautious about and very uh, careful about. Why so? Because this wireless network is always available not just to the authorized users, but also to the unauthorized users who are not possibly allowed to access some resources. But because they can reach this network anytime, they are able to perform attacks, they are able to try authentication, and that's why security becomes a major uh, area to be addressed in a wireless network. Make sense? Then another pro here of wireless network is it is simple and can be temporary. If, for instance, I want to deploy a network just for 5 days, a wireless network would be a better choice because I really don't have to take care of installing any cables or mapping the devices correctly. All I need to do is I need to deploy my wireless devices appropriately. And that's going to help me deploy that temporary network, right? So it is ideal for quick and straightforward tasks where let's say you need a network for some amount of time. Now there is a type of wireless network called ad hoc wireless network. Ad hoc wireless network enables direct communication between the devices. Let's say this is my smartphone and this is my smartwatch. Now, when I connect them together wirelessly, that type of connectivity can be considered as ad hoc wireless network. Clear? Now, in this type of connectivity, you do not require any infrastructure. So, no infrastructure needed. What does that mean? That means no special devices are required for making them communicate. Then this is also a good example of something temporary and simple, right? A very nice example where I want a temporary connectivity between, let's say, my two of the devices. I can use an ad hoc deployment there. But what do you think? Is it scalable? Can I use this type of connectivity for my whole company or my organization? Yes or no? No, right? So definitely this is not scalable. So I can say it has a limited scalability. Not suitable for we can say businesses or organization having multiple devices. But then there are some other types of infrastructures also which we can use for our organization setups. One we have discussed, which is ad hoc, which is a very small network created for only small personal area connectivity, can be catering an area of 5 to 10 meters, right? And this type of connections are called as PAN, as we have discussed earlier, personal area network, right? Then there comes WLAN. WLAN stands for wireless local area network. Now, in a wireless local area network, things change. Now you are connecting multiple devices together. It's no longer an ad hoc network, it's an infrastructure network. So it definitely requires some additional points. What are these additional devices or additional, we can say, infrastructure which we require? Let's discuss. First of all, you require wireless clients. Now, if you're talking about deploying a network in your organization, you need to make sure that the PCs or the laptops or the tablets that your employees are using, they do support wireless connectivity. Like back in time, I remember the last workstation I was using. It had a simple network adapter and it was a wired network adapter. It didn't have the ability to connect to Wi-Fi networks. So that ability should also be there. The network adapter you have on your devices should be capable of connecting to wireless networks. Nowadays, all the laptops do get this wireless network adapter, but back in time, it was something that you will have to get additional installed on your device. So wireless clients is one device. I mean the device type of device that you need in your network connectivity, laptops, smartphones, computers, which can connect wirelessly. Then there is a device called access points. Access points are those devices which connects with wireless clients. For example, in our wired connectivity, we have a switch, right? Switch is responsible for connecting to all the clients. In a wireless connectivity, there are devices called access points. So if this is your router, this is your switch. Switch would be connected with multiple access points. And these access points transmit radio frequencies. So they actually create the wireless network, right? They transmit radio frequencies like this to which a user can connect. Then there are two types of access points which we are going to discuss. Two types of access points are there. But before we jump on to that, there is another third type of device called WLC, which stands for Wireless LAN Controller. It's a controller which we use for managing and configuring the access points. But before I move there or discuss further about the types of uh, access points and what is WLC, how do they work? What are some benefits that we can expect from a wireless network? Any guesses? Like when we connect with a setup like this, where there are access points and there are clients which connect to it, what are some benefits that we will receive? Let me know in the chat. Scalability is there, very correct. Like anytime I want to extend my network, I just need simply uh, adding some more devices, more access points to extend my coverage, maybe in another part of my building. So scalability is one point or a feature of a wireless network. What else? Easy to connect, perfect. Mobility, mobility is there. A user can be moving from this access points coverage to the other one without facing any disconnection, right? They can take up their laptop and can go up to the other point or point B without facing any disconnection. But that also is planned very, I can say, rigorously and has to be understood with a lot of physics concepts as well. So when we deploy access points in in an organization, we need to make sure that we understand how much area it would be covering. And accordingly, we put the second access point in the other area so that there can be some overlapping frequencies. And we can make sure by doing this that when a user moves from here to point B, it doesn't have to face any disconnectivity. Then other things like disturbances of wall or maybe some other devices or certain installations has to be taken care of. All these calculations are done, and on that basis, further the access points are deployed. So it's definitely a very critical task for anyone, but that's not our concern as of now. That's basically someone having an expertise in the wireless network is supposed to do. But after that, after deploying all these access points, all these wireless infrastructure, we can definitely say that we get the scalability as a pro, as a, and then ease to connectivity is also something which we get from a wireless network. Mobility is something we get from a wireless network. But then many of you have mentioned that it's going to have a low cost. That's not the case, guys. I definitely can say that it saves a lot of cost by, by not requiring cables. But these devices are expensive enough to not let you minimize the cost. So cost saving is not something which we are able to achieve with completely wireless networks, but we can definitely say the cost of cabling can be avoided. So I can add a point here that cost of cables can be avoided. Now I said that there are two types of access points. What are these two types of access points? Let's understand. So there are two types of access points: autonomous access points and lightweight access points. First, we will learn about autonomous access points. Autonomous access points are those access points which operate independently. They don't require any other device to manage them. These can operate independently. You can manage them individually. Okay. They do not have any connectivity with any controller or any device that can manage them. So first point is they operate independently. Then individual management is there, right? So no central administration. And is something which is suitable for small infrastructure. Why do we say small infrastructure? Because let's say you have 50 access points, then managing them independently one by one, which means like independently means when they operate independently, that means you will have to configure and manage them individually. So if your organization or if your network have 50 access points, you'll have to connect to all 50 of them one by one to configure them. That's not a good idea, right? So it's only suitable for small infrastructures where there is a requirement of, let's say, very less access points. So this also brings simplicity and are cost effective. Then we have lightweight access points. Lightweight access points are those access points which are managed through these are managed through a WLC, which is wireless LAN controller. Remember, I told you about this device, wireless LAN controller. So in this type of connection, there is a wireless LAN controller which gets into picture and it does central administration, or we can say centralized administration. Now, because there is a centralized administration, scalability is one of the feature which it offers. You can add many hundreds of access points into your network, and you'll be able to manage them or configure them easily from a central point of contact, which is your WLC. So scalability is one thing which we get. Then there is a kind of, we can say, uh, feature, enhanced features like mobility, security, etc. Because there is a centralized management, you can implement security policies, you can implement connectivity between access points in a much simpler and easier manner. So it makes it possible for you to deploy a network on a wide scale in a simple and easy way. But you definitely requires a additional device for it, which adds up to additional cost of WLC. But if you have a big network, let's say you're deploying a wireless network for a shopping mall. On this shopping mall, there are 7 floors. In each and every floor, there are, let's say, around, uh, let's say, 15 access points. So all these access points would be able to configured with the help of a single WLC, and that will allow me to manage the complete infrastructure of that shopping mall directly from this WLC. Okay, so all you need is you need to connect to this WLC and you configure WLC. This WLC maintains some tunnels with access points on which it shares configuration with them. These tunnels are called CAP-WAP tunnels. Clear? And CAP-WAP stands for Control and Provisioning of. I'll write it here only. CAP-WAP tunnels are maintained by WLC with the access points to share information with them. And CAP-WAP stands for Control and Provisioning of Wireless Access Points. Let me know what questions or doubts do we have so far regarding the concepts we have discussed. CAPWAP tunnel is used by WLC for sharing data or sharing information with the connected lightweight access points. We said that WLC will be managing these access points, right? So to manage them, it has to send some configurational data to the access points, right? So to send this data in a secure and safe manner, we use CAPWAP protocol, which is basically which will allow WLC to manage and configure the access points. Now, Ankush, with one WLC, we can manage multiple access points. Any other questions? Yes, exactly, Sayed. Like I said, CapWap is a tunnel between WLC access point to transfer the data so that you can manage and configure your access point centralized in a centralized manner directly through your WLC. It is secure. Autonomous is also equally secure. It's just that in autonomous access points, if you have to manage this access point, you'll have to connect to it individually. You cannot manage all of them directly from a central point of contact. Then there is a term SSID. Does anyone know what is the full form of that? SSID stands for Service Set Identifier, which is basically, which in simple language, Wi-Fi names, exactly, Wi-Fi names in general. So these Wi-Fi names that we see, so for example, if I check my Wi-Fi name, I have multiple Wi-Fi connections coming here with different names, right? So all these Wi-Fi names are nothing but SSIDs. In the technical terminology, we call them SSID, which is Service Set Identifier. Your Wi-Fi network or a wireless network can have multiple SSIDs, maybe one for sales team, one for tech team, one for management team, and so on, right? So when you connect to a SSID, you have to provide some password to get yourself authenticated, correct? This type of authentication. Now, security is a big concern, like I have been saying since the beginning in a wireless network. So there are different types of standards and protocols which we use for implementing security in a wireless network. We'll speak about them, but the way how we connect usually to Wi-Fi networks is PSK, using a PSK. What is PSK? PSK stands for pre-shared key. Pre-shared key is the simple password which we configure on a Wi-Fi network, and we use that further to connect all our devices with that particular Wi-Fi network. This is the setup usually we use in our home networks, right? We have a Wi-Fi, we have a network, and then we use some password to connect our devices with that Wi-Fi network. But do you think it's logical to use PSK in enterprise also? No, right? Because see, very simply, first of all, I cannot share my password with, let's say, hundreds or thousands of employees. And even if I do, it will become highly insecure, right? Anyone would be sharing their password with, let's say, someone else. The other person would also be able to connect to my network. So pre-shared key is only suitable for small offices or home environments. Correct? Then it is non-scalable. It doesn't scales well on a large network due to the manual configuration which would be required. If there are thousands of devices in my network, I cannot go on all of them and put a password to connect all those thousand devices with my network, right? Then we have got another method, which is the enterprise mode. Now, just like pre-shared key, there is an enterprise mode of authentication. In the enterprise mode authentication, things become a little better. The authentication process becomes more complicated and provides credentials to all the users. So now in the enterprise mode, there is a username and password, both required for getting yourself authenticated with the particular access point or the wireless network. So this one is more scalable, right? It's more scalable and secure for large networks. It enhances the security, right? Now to implement both the pre-shared key or the enterprise mode authentication, there are different standards that get into picture. There are various standards which we can speak about, which allows us to implement security in a wireless network. The very first standard which we can talk about is WEP. WEP stands for Wired Equivalent Privacy. This was, we can say, one of the very first security implementation observed in wireless networks. And the name suggests that it is something, it's a privacy comparable to that what we achieve in a wired network, right? As it says, wired equivalent privacy. But unfortunately, it failed to achieve that. It was not really secure. And we realized that cracking the keys of WEP was quite simple and easy to do. Then the evolution of these security standards happened, and we got WPA. WPA stands for Wi-Fi Protected Access. Wi-Fi protected access came out as a temporary solution to replace WEP. WEP was weak, definitely, but WPA was also not very secure. It came out as a solution, definitely, but again, having a very weak level of security, we decided to proceed further again with a revolution, or we can say again with an enhancement, which came out as WPA2. Now, WPA2 was really a kind of standard which became hero of wireless security, which is nothing but Wi-Fi protected access 2. Yeah. This came out very strong. This became a very favorite one for everyone over the period of 2006 to, I believe, 2018. And not 18, I guess 2016, 17. So this was the one that we always used for implementing the security as it brought encryption and authentication into the scenario. It made sure that the data which travels between the devices is secure and encrypted. Is something which can be captured probably by others, but not can be understood because it's encrypted, right? But then later on, late in 2016, there was a vulnerability which was observed with WPA2 called crack. Now, crack stands for key reinstallation attack. Then later, to address this vulnerability crack, we got our final revision of WPA, which is WPA 3, which is the current version. It was introduced back in 2018, and we are still using it for our wireless authentications or wireless security. It has got a much more enhancements in the security part and makes it the most secure and highly uh, stable option to use for a stronger encryption, for a stronger authentication, and to avoid any sort of attacks in a wireless network. So WPA3 is the most recent one, which we are currently working with. All these are the security protocols, and this is how they have evolved starting from WPP to the WPA3 options. Let me know if there is any questions or doubts. The limitations of connecting devices depends upon the reachability, the processors, the resources of the device. There is no such defined number, but how many devices or how much traffic a device can handle, that completely depends on the resources which it has, right? So that can vary every time. The WPA is not just a password security, is also used for data transferring. Like I said, it introduces encryption as well into the scenario. So the data, the keys which will travel between the devices, they are going to get more stronger encryptions, making it harder to crack. So that makes it, a better enhanced version of security. All right, we'll try to explore some devices here on Packet Tracer. And I would like to tell you first that wireless labs can't be done a lot on these simulators. I mean, you can do a basics definitely, but because wireless devices can't be virtualized, there is a limitation of labs which we'll be addressing. Uh, but yeah, Cisco Packet Tracer do offer some of the basic devices which works sometimes and sometimes they don't. So we'll see if we can test some of the configurations and I can make you introduce to some GUI or some uh, interfaces of these wireless devices. I'm sharing my other screen. Let me know once you can see the Cisco Packet Tracer. All right. So here, if you see, there are different categories, right? There is network devices, end devices, connections, miscellaneous. Under the network devices, there is a section called wireless devices. If you click on wireless devices, you will see all the devices which are there. There are Wi-Fi routers, there are servers, there are access points, there are WLCs, and so many other things. So what I'm going to do is I'm going to take one home router. This is a wireless router, which also has, you can see, there are antennas for transmitting the radio frequencies. Now, wireless networks work on two radio frequencies. Can you let me know what are those two radio frequencies in the chat box? 2.4 gigahertz and 5 gigahertz. Perfect. When we speak about 2.4 gigahertz channels, they allow you a better reachability. So it can be expanded for a longer area, can be used for covering a longer area. But they offer a limited amount of speed. On the other hand, when we speak about 5 gigahertz spectrum, this can not cover a lot of, this cannot probably cover a very big area, but it definitely offers a better speed comparing to 2.4 gigahertz. Nowadays, there are multi-band routers which are installed in our homes as well, which is also the reason why we sometimes see two SSIDs with the same name. One stands for the original Wi-Fi network. Let's say in my case, the wireless network is known as Chirag. So one will be Chirag and the other will be Chirag 5G, right? So that's not basically two networks that we are creating. That's just the same network transmitted over two different bands of frequencies. One is the 2.4 gigahertz, which you would observe that covers a larger area. And the other is 5 gigahertz, which covers a lesser area but gives you a better speed. Now, here in this setup also, I have added a wireless router. And with this wireless router, I'll try to connect some wireless clients. These wireless clients can be found in the miscellaneous folder. Here, this PC and laptop which you see, these are wireless PC and wireless laptop. So if I add a PC here, like this, I'll be able to connect with this wireless router. Now you can see automatically connection got established because as of now, there is no password or security implemented on my wireless router. So they all got connected and they will also get IP address using DHCP. If you will check the IP configs, they have already got the IP. See? And I can check the reachability also between them. Like this was 0.100. And if I check the IP here, it is 0.101. So I'll go to PC 0. I'll try to ping 192.168.0.101. You can see I'm getting my replies. That means these two devices are connected wirelessly, right? All these devices basically are connected wirelessly. And we can also manage this wireless router from my PC itself. So if on my PC I go to my browser and I type down We are in my browser. Here I'll type https://IP of my gateway, which is 192.168.0.1. Enter. It will ask me for a username password. I'll give the credentials admin. That's the default credentials for my Cisco packet tracer devices. I'll say OK. And you will see we get the GUI access of my wireless router. GUI stands for Graphical User Interface. Graphical User Interface means just like you manage Wi-Fi, I mean the normal router using CLI, now you have a graphical user interface. Means a graphical image is there or a graphical portal is there for managing the configurations. If you want to enable something, if you want to disable something, all you need to do is you need to check the boxes like you can see here. So here you can see the IP address of my router, which is 192.168.0.1. If I want to change it to something else, I can do that. I can enable or disable DHCP. I can tell what should be the start IP address for DHCP, how many maximum users can be connected, what will be the range of IPs, how many clients are connected, what DNS IP I want to configure. I can do all of that. If I want to set VLANs also, I can do that directly from my wireless router. Then under the wireless tab, I can see the two bands or all the bands which are there, 2.4 gigahertz, 5 gigahertz, and so on. So here I have the first band, 2.4 gigahertz, which I am disabling. 5 gigahertz, second band also I will disable. I'll just keep one 5 gigahertz band open. And to this one, I'll give a different name called, let's say, PyNet Labs. Okay. Then I'll keep the other things as auto only. And lastly, I'll say save settings. Yeah, you can see there is a disconnectivity. Soon they will connect back again. And this time they would have connected to network PyNet Labs, right? We can even confirm that. I'll go to PC1, let's say. And here there is this PC wireless option. If you click on that, you will find out that these devices are connected to a Wi-Fi network called PyNet Labs. There you go. See, PyNet Labs. Other than that, you can also set password to your network from the GUI of Wi-Fi router itself. I'll show you how. As the network was open, they were able to connect with it automatically as there is no password right now. That's why Sayed, they got connected. But now we'll try to configure password and we'll see how authentication can also be implemented. So now we are back onto the GUI. Here we have a tab called wireless security. If I go there, I can enable security for 5 gigahertz -1. Now you see, we have got all these standards which we have discussed. I'll go for, let's say, WPA2 PSK. The encryption we are using is Advanced Encryption Standard, AES, and the password I would like to configure will be, let's say, Chirag@123. Once I do that and I scroll down and I say save settings, my password will get implemented. And now I will need an authentication to connect with this particular network. Save settings. Now I'll go to PC1, let's say I'm already connected. I'll try to click on network and say, let's first of all refresh. you can see the connectivity is lost. If you will go onto these devices one by one and you will click on refresh, you will find the connectivity getting lost because now there is a password. So if they want to connect to this particular network, they will need a password to authenticate and then further connect with the network, right? So now here, in order to connect with this network, as you can see, I have to enter a pre-shared key. If I'll put the correct password there, only then only I'll be able to connect with it. I have entered the password. I clicked on connect. Let's see if the connectivity gets established or not. Okay. I guess I have added a wrong password. It was chirag@123. Connect. Yeah. So, yep, once we enter the password, we can see the connectivity getting established. If I go to PC1 also and I say I want to connect to this and I give the correct password, chirag@123, I'll be able to connect with the network. Here also, like these representation of connectivity is there, but the device is actually not represented. The device is actually not connected. If I go on to device and I refresh a couple of times, this connectivity will be lost. So yeah, this is how the authentication is enabled. How do we get to this window? Go to desktop, PC wireless, and you will see this options of connecting to the network. Let me refresh on this third PC also. Click on PyNet Labs, connect, enter the password, click connect, and your connection will get established. Now, this is exactly how it is managed in real life also. For example, if I go to my browser now, this is my browser. On my browser, if I enter my gateway IP 192.168.1.1, I'm not sure if it is 1.1 or 0.1. Meanwhile, I'll quickly confirm that. It's 0.1, my bad. So if I enter the IP 192.168.0.1, you see I get my Wi-Fi router's GUI page, and I can see and manage various things from here. I can see the speed. This is an extended router, so I can see the speed. I can see the connected devices. I can check the settings. I can change password, use a different mode of security if I want. I can control bandwidth. I can control. I can put parental controls. I can block websites and all. I can turn it off. I can set MTU, various things I can do directly from this particular page, right? So this is how it is accessed and managed in real life also. But guys, I will not suggest you to play around with your home Wi-Fi because this can lead to a disconnection also. You can experiment things with the packet tracer Wi-Fi router. Look around all the options which are available in the Wi-Fi router and see how settings are working for you. So take your time, experiment with it, and let me know once you are done. Then we will move to the next discussion, which is about IP version 6. So you have to get a wireless PC from the miscellaneous section. If you will find there is a device called wireless PC which you can add. This is how you can access the frequency settings. Once you are on the GUI page, you have to click on wireless. There you will see all the basic wireless settings, and under wireless security, you can set up the passwords. Guys, when you will open the setup page, like when you open the first page, here you have the tab wireless, where you can access these settings. Okay. Guys, under the wireless devices, you have to use home router. You will see there is a home router that you have to use. I'll give you 10 more minutes to complete this, and then we will move to the next topic. Please take home router only, and then you will be able to see all the options. I hope those who had issues with selecting the correct router must have checked the configurations by now, and we are good to move ahead. Is there anyone facing any queries or doubts with the concepts? All right. So now it's time when we speak about IPv6 and understand how IPv6 addresses are different from IP version 4 addresses. I'm going to share my other screen. All right, my screen must be visible now. So now we are going to talk about IP version 6 addresses. IP version 6 is an address, another version of IP address, having much more better features and better address space as compared to IP version 4. Many of you would have already been aware of that we are out of IP version 4 addresses, right? Like there is no more public IP version 4 addresses available to be used by organizations or companies. Then the question is that if we are already out of IP version 4 addresses, why are we still discussing all the protocols, all the concepts still in the context of IPv4? Like it's IPv6 time and we are out of IPv4 addresses. Then why our whole CCNA training was based on IPv4 addresses? The answer to this question is that IPv4 has not gone yet completely from the network industry. IPv6 is definitely the new address that we are going to use and would be working with in the coming period of time. Already, there is no more IPv4 addresses available. So many ISPs are assigning IPv6 addresses. Geo is a good example of that. Geo ISP of India is providing or working with IPv6 addresses. Now, does that mean that IPv4 addresses are something that we need not to study about? Definitely not. The industry is still based on IPv4 addresses. We still use them. We still will have to work with them. So learning IPv4 is equally important as it is IPv6. Okay. So now when we speak about IP addresses, we said there are two versions, right? IP addresses are available in two versions, IPv4 and IPv6. IPv4 address is made up of 32 bits, correct? And it was written like this, 192.168.1.1. This form of the address is called dotted decimal form. When we talk about IPv6 addresses, they are of 128 bits and are written in hexadecimal form. Clear, guys? I'll tell you the idea of how big IP version 6 addresses are. IPv4 addresses has 32 bits. And if you say 2 raised to the power 32, you will get a number near to 4.3 billions, which is basically the maximum addresses the IPv4 address space can provide you. Okay. Now, when we look at this number, it looks quite big, right? 4.3 billion is a very big, huge number. But when we compare it to the internet users, it became very small. Over the period of time, we realized that these number of addresses would never be enough for catering the requirement of internet users. Everyone here are connected on internet, right? Internet is something which is used on each and every device mostly, right? That we use today. So we realized that there is a need of many more IP addresses that could keep us connected to the internet. So to make sure that we secure or we preserve the public IP addresses, we got the technology VLSM, or which we call as subnetting. Remember, subnetting helps you in minimizing the extra utilization of public IPs. You can avoid the wastage by implementing subnetting there. Similarly, we spoke about a technology called NAT a few days back. NAT also allows you to use multiple private IPs for making communication and just using a single public IP after translation, right? All these features were definitely helpful to minimize the overutilization, but none of them was a permanent solution. That's why we had to switch to IP version 6. Now, when we went to IP version 6, we got a very, very large address space. I'll give you an idea of that. What is, guys, 2 raised to the power 2? Let me know in the chat. 2 raised to the power 2 is 4. And what is 2 raised to the power 3? 8. Correct? So we can say as the power got incremented, the value got doubled. If I'll ask you what is 2 raised to the power 4, what would that be? 16. So every time the value is getting doubled. Similarly, 2 raised to the power 32 is somewhere around 4.3 billions. Correct? What would be 2 raised to the power 33? Can I say somewhere around 8 billions? Yes or no? Yeah. 2 raised to the power 34 would be something 16 billions. Now you can imagine the address space of IPv6 is 128 bits. So 2 raised to the power 28 would be a so big and huge address space that we will never ever face a shortage of IPv6 addresses. We are highly secure in terms of IP addresses for future when we are using IPv6. Now you can just imagine by just, multiplying the numbers and doubling the values. 16 billion, 32 billion, 64, then 128. I mean, if you will go in the exact figures, 2 raised to the power 128 is a number which is in trillions of trillions. So it's so big or so huge that we'll not face any shortage in the future when we are using IPv6 addresses. Now we said that the IPv6 addresses are written in hexadecimal form. So a hexadecimal form includes numbers starting from 0 to 9 and then also the letters starting from A to F. I'll give you an example of IPv6 address. An IPv6 address looks like this. Let's say 2001 colon AB12 colon 1234 colon, let's say 0034 colon 56 AB colon 0D05 colon 1234 colon AB78. Yeah, this is in random IPv6 IP, which I have written. Each and every group here is made up of 16 bits. How many groups do we have? 1, 2, 3, 4, 5, 6, 7, 8. So 8 multiplied by 16 is going to give you 128. So the total size of your IPv6 address will be 16 multiplied by 8 groups, 128 bits. Make sense? And every character is made up of 4 bits. So a group has how many characters? 4 characters. 16 divided by 4, 4 bits. So your number 2 is made up of how many bits? 4 bits. What are these 4 bits again? 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3. These are the 4 bits which we use for creating a character inside my group. Any questions or doubts so far? All right, we will try to translate all of our characters, 0, 1, 2, 3, 4, all of them, into binary by using these 4 bits. So let's see how that goes. We said that hexadecimal includes numbers starting from 0 to 9. So there will be 0, there will be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We'll try to put them into binary using the 4 bits, which are 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, and 2 raised to the power 3. So if it is all 0, we'll get the outcome as 0, correct? For 1, it is going to be simply 0, 0, 0, 1. For 2, it will be 0, 0, 1, 0. For 3, it will be 0, 0, 1, 1. 4 will be 0, 1, 0, 0, right? 5 will be 0, 1, 0, 1. 0, 1, 1, 0, 0, 1, 1, 1, and 1, 0, 0, 1. Correct? Other than these 10 numbers starting from 0 to 9, we also have some letters, as I said earlier. The letters are A to F. So A represents 10, B represents 11, C represents 12, D 13, E 14, and F 15. So for A, we'll have the binary as 1010. That's going to make it 10, right? For 11, we'll have 1011. For 12, we'll have 1100. 13, 1101. 14, 1110. And 15, 1111. This is how all the characters of your hexadecimal address or IPv6 address can be translated into binaries. Any questions or doubts? Okay. Now I'll teach you about 2 rules which can be used for shortening the IPv6 address. So there are 2 rules for shortening down the IPv6 address. The first rule says you can ignore leading zeros of any group. What does that mean? For example, if you have got a IP which looks like this, let's say, so you can ignore the leading zeros. These two are the leading zeros in this group, so I can ignore them. I can just ignore typing them. Here also I have a leading zero. I can ignore it. Similarly, if you have got an address which has got groups having zeros in the beginning, for example, 2041 colon 0000 colon 00 AB colon, let's say 1234 colon 1000 colon 0000 colon 0560 colon 1378. Yeah, this is my IPv6 address. So as per the first rule, I'll say 2041 colon, and I said I can ignore the leading zeros. So I can ignore the first three zeros and just put 10 here. Then here also there are two zeros in the beginning. I can directly write AB 1234 colon 1000. I cannot ignore the zeros at the end. Okay, I can only ignore the zeros which are in the beginning. Colon 0 colon 560 colon 1378. So this would be your shorter form of IPv6 address. Make sense? Okay. The rule number 2 says you can replace series of zeros with double colon once per IP address. If there is a series of zero, you can ignore it and you can replace it with a double colon. But you can only do it once per address. I'll show you why. 2001 colon 0000 colon 0000 colon 00 AB colon 1234 colon 0000 colon 0000 colon 5678. This is my IPv6 address. Okay. Now there are two series of zeros. First series is here. The second one is here, right? What I can do is instead of typing them, I can just type double colon in the place of it. So I replaced this series with double colon. Then AB colon 1234 colon. Now again I have a series, but I cannot use double colon for it. I'll teach you, I'll let you know why. As of now, I can ignore the leading zeros and just type 0, 0, 5, 6, 7, 8. Now let's assume that's, let's say you were not provided with this IPv6 address and you were just provided with this shortened IPv6 address. Okay. So when you look at it, what you will do, you will count the number of groups. 1, 2, 3, 4, 5, 6. So when you see that there are 6 groups here, it will give you the understanding that out of 8, if 6 are here, then these two columns are replacing two groups of zeros. Make sense? But if this double column was twice in my address, let's say my address was 2001 colon colon AB colon 1234, again double colon 5678. So as per this logic, 1, 2, 3, 4. That means my double columns are replacing 4 groups. But we don't know that if three groups were here and one group was here, or if one group was here and three groups were here, right? We don't know the distribution. So that's why we can only replace a series of zero with double colon only once per IP address. Is that clear, everyone? Perfect. So these are some methods through which we can shorten down the IPv6 address for our ease of access and using. And then these IPv6 addresses can be configured further to implement configurations and making devices speak with each other. That's something we'll try to discuss in our session tomorrow. We'll look at some labs and we'll also be talking about the different types of IPv6 addresses which are there. So as of now, this is what I wanted you guys to learn. Tomorrow we will continue the discussion. We'll learn about some labs and we'll also be speaking about automation and programmability. Also, this is going to be the last session of our free CCNA training. So I'll be guiding you with some good, helpful material, and that material will help you in preparing better for your CCNA and also for your interviews. So make sure you do attend this last session, and yeah, I'll paste the notes. So thank you so much again. I hope you enjoyed the class, and thank you. I'll see you tomorrow. Bye bye. Take care.